अब स्टूडेंट्स कुछ बात करेंगे अबाउट आर सोनेट फ्रेम्स. Students, each of our STS signals, doesn't matter what the specs of this STS signal is, it consists of 8,000 frames. Students, each frame is a two-dimensional matrix of 9 rows and 90 into n columns. Students, in this case, for example, of STS-1, because it's STS-1, the value of n is 1. So it will consist of 9 rows and it will have 90 columns. Students, 9 rows and 90 columns because we have got the number of columns is represented by 90 multiplied by n. And in the case of STS-1, the value of n is 1. Students, 9 rows and 90 columns, it corresponds to 9 multiplied by 90 equal to 810 bytes. So students, in the case of STS-1 signal or STS-1 frame that we're talking about, each frame is carrying 810 bytes. Students, in the case of STS-3, we have got 9 rows and 270 columns, 90 multiplied by n. In this case, 90 multiplied by 3, which is 270 columns, and therefore we have 2,430 bytes that make up an STS-3 frame. Now, students, on the slide, you'll see the exact same concept that I explained to you. You've got 9 bytes, bottom figure first in this slide, STS-n frame. You've got 9 rows, which consist of 9 bytes, and then you've got 90 into n bytes, which make up our columns. And so you have got 810 into n bytes. It represents how many bytes are we going to have in our particular STS signal. और मैंने आपको example दी थी STS-1 frame की. In this particular case, 90 cross n is actually equal to 90 cross 1, and therefore we will have 90 bytes in the horizontal direction. We have 90 bytes in the vertical direction. Multiply those two, and you'll see that an STS frame it consists of 810 bytes. And remember, doesn't matter what particular STS spec we are using. We will have 8,000 frames that make up an STS signal. Students, the transmission of the SONET STS signal, it is once again transmitted at 8,000 frames per second. So this is our frame rate, and as you can see, it is transmitted from the most significant bit to the least significant bit, left to right, in the order of the byte transmission, as you can see. Students, first byte is this byte in a frame, and then it will keep on moving left to right, top to bottom, and ultimately it will reach the last byte out here, and this is the order of the STS-1 frame that is in transition. Students, we'll do an example. In this particular case, we need to find the data rate of an STS-1 signal. As I told you earlier, each STS signal, it sends frames at the rate of 8,000 frames per second. In the case of STS-1 frame, it is made up of 9 by 90 bytes. So I told you 9 bytes in the vertical direction, or the number of rows, and then you have got 1 cross 90 into n. So 1 cross n bytes in the horizontal direction. So students, data rate calculate करने के लिए we will multiply these together. So you will have your frame rate, which is 8,000 multiplied by 9, and then you will have 1 into 90, and this comes out to be 51.84 megabits per second, and that is what I showed you when we were talking about STS signals as well. Students, very quickly, doing the same calculation for an STS-3 signal, we get the data rate as 8,000, and in this case we have got 9 bytes, but in this case we have STS-3, n is equal to 3 in this particular case, multiplied by 90 bytes, and this comes out to be 155.52 megabits per second. Students, in the case of STS signal, there is a very interesting relationship that I already expose you guys to, and that relationship is that the data rate of different STS signals, they are in an exact multiplication relationship. For example, if you multiply STS-1 data rate by 3, you get STS-3 data rate. And similar relationships also hold, and I'll explain to you why these relationships hold, because we need to do multiplexing and interleaving, and we'll talk about that in our later discussions. Students, before we leave this discussion of STS frames, we'll talk about an example STS-1 frame format as well. As I told you, SONET frame, it's a matrix of 9 rows of 90 bytes each, which makes up 810 bytes in the case of STS-1 frame. Students, out of this, the first 3 columns of the frame, they are used for the section and your line overhead, and the upper 3 rows, this bit out here, this represents your section overhead. The lower 6 represent your line overhead, and the rest of the frame that you have got on the right hand side, it's called the synchronous payload envelope. So your SPE stands for payload envelope. And students, just one extra point that I need to mention out here. The reason it is called synchronous optical network, and the reason it's synchronous payload envelope, is because we use clock for synchronization, which is synced up to a master clock. So we have got a master clock in a SONET network, and all the synchronization actually happens by using this particular master clock, and that's why we call this as a synchronous optical network as well. And students, our user data goes into this particular area of a frame, and we have got the path overhead which resides in this particular frame as well, and this consists of 9 rows into 87 total columns.